The problem that we need to solve in this PBL is to find the distance that the racers actually traveled during the race. The precision of the NASA GPS only gives us the velocity, so we need to know the distances with ups and downs on the road. In order to have a better analysis, we analyze the graphic, velocities and times of the racers. Using method of Riemann sum to get the area under the curve and the integral of velocity to get the distance.
We need to get the distance traveled by a group of racers through time using only basic equipment as well as the data given by the NASA. The main obstacle is that the data that we obtained from NASA's GPS wasn't accurate, so we need to figure out a process that leads us to obtaining the answer.
The first idea we got to solve this PBL is using the integration of the function, because we know that the function was given by the velocity and the distance is the antiderivative of the velocity. Then we might get the function of the graph. Another idea that was the most difficult was the way to get the area under the curve of the graph. That is the same as the total distance traveled.
What we know, the data the NASA gave us using the GPS, the topics we saw in class, sum of Riemann to get the area under the curve, and integrate the trend line to get the total distance traveled. What we don't know, the correct graph of the data, the total distance traveled, as we already know, it is what we're looking for. We don't know if the racers are cars or just people, but this isn't important to get to the answer. To do the sum of Riemann using Excel tools, and the degree of the polynomial just by looking to the graph.
After discussing with the teammates, we concluded that we can obtain the answer by using two different methods, sum of Riemann and by integrating the velocity function.
As they already said in the methodology, the two methods we choose was sum of Riemann and the integration of the function of velocity to get the distance. The sum of Riemann, the NASA gave us two values, x in seconds and y in meters over seconds. We all know that we should have the equation of the graph, but as we have the height is the value already substituted in the equation. The equation is no longer necessary. As we did the Excel, we obtained the result of the distance using the method of sum of Riemann. The area under the curve is represented by the integral, and in this case, as we have the velocity, we should get the distance. We did Riemann with 180 bars because in each second the distance was 1 and the width of the bar was 0.5. We had 90 seconds in total. The other method we chose was integration of the function of velocity. The first step was to get the equation from the graph. We did that with a grapher. Integrate the equation given by the graph. We did a graph with the 8 degree to get as much possible to the closer to the original graph. We did the integration limits from 0 to 90, talking about seconds. Evaluate to get the total distance traveled, and then we eliminate the negative parts by multiplying by 2 and adding the other area. We did two different integrals. One got us 1198.12, and the other one that was the negative part, we got 20.99. We multiplied this one times 2 and then we added to the other area we got. So the result doing both methods, we got 1240.1 units square.
At first, we thought we wouldn't be able to do it. We thought it was too hard for us to solve it. But after reading again the problem and clarifying the unknown concepts, we realized we were actually able to solve the problem. We know we could use different methods, so we choose the two we have found more convenient to apply, and with both methods we got the same results. This also served us to prove our methods and results were right. This PBL taught us we have more than one way to solve the problems, involving distance traveled, velocity, and acceleration. This means that by considering the data we are provided with, we can determine what method is the most convenient one. apply it, and use to solve our problem.